Hello guys, welcome to Moving Beyond CLI, a beginner's guide to network automation and APIs with me, Joe Neville. There I am down in the bottom left hand corner. So this is a presentation about network automation, and if you've been through any other prezos about network automation like I have, you probably have experienced this, where you get blasted with strange sounding names of things such as Vagrant, Jenkins, Puppet, GitHub, all of these great things which come from other areas of IT, mainly from software development and from server infrastructure, and you struggle to see how they are applicable to networking, like this little chap here in the middle. Where is the networking in all this? Well, that is a very good question. So in this presentation, I want to try and do something a bit different. I'm not going to go through each one of those lovely icons and those different features. What we're going to do is I'm going to try to impart just some really basic information about the beginnings of network automation and how you can start to think about moving beyond CLI and how to make your first steps with network automation. So the agenda is that we can't type fast enough. The CLI, what is it and why must we move beyond it? Then we're going to look at machine to machine, how they talk, and the idea that APIs are everywhere. I'm going to be talking about what APIs actually are. Then we move on to the importance of structure. Then we are going to be showing this off by using the go-to programming language for networkers, that being Python. And then finally, a word of caution: with great power comes massive outages. Okay, so we can't type fast enough. So the CLI, if you're a networker like me, you probably spent a lot of time on the CLI. So entering commands, that's the command line interface that we use to interact with network equipment nowadays. There are other forms of interaction, I'm sure you're aware, like SNMP. Now, I'm not actually going to be talking about SNMP here. Apologies for that. But we are going to focus on the CLI. So this is where we enter commands to interact with network devices. So what's the problems with the CLI? Well, it's humans, humans and humans. So humans make mistakes. So there's inherent risk when using the CLI. You can put the wrong IP address or the wrong command. I'm sure we've all had that cold feeling when you enter the wrong command and the screen goes freezes because you've just cut yourself off from a device. These are risks. So there's inherent risk in the CLI. Other problems are the fact that the knowledge and process around the CLI. So if you think about it, some people's job within networking, not to criticize them, but in some of the, say, first line troubleshooting roles or second line troubleshooting roles, are very much process driven, and that process is built around not actually kind of networking concepts as a whole. Sometimes it's actually just around the process of the CLI, so entering commands and then getting the output. So not really delving deeper into what's actually happening on the network, merely just kind of call and response from the network using the CLI. And then finally, humans are a problem in the fact that we can't type fast enough. The CLI itself is, I think, inherently inefficient. If you think of a typical CLI interaction, I know this is the kind of thing that I see or I do quite regularly. So we got step one, two-finger typing. We hit enter as we enter our command, then we read that in output. Think about it, slurp our coffee, think about it some more, smash enter 5 times because we don't get the response that we want to see. Now, as we move into the world of the Internet of Things, when every switch, router, car, TV, phone, AP, PC, light door, lift, fridge, oven, camera, gate, thermostat, toy bike, toothbrush and toilet are on the network, how do we manage it all? So the CLI for all of these different devices, how are we going to be able to control them if we're doing our two-finger typing and smashing enter 5 times each time we want to just enter a single command? So if you think about it, the CLI is essentially human to machine interaction. So it's one connection at a time. What we really need is we need some automation. We need to offload these tasks of controlling the networks to other devices, so to machines. So we need machine to machine interaction. We need automation. Okay, so machine to machine. So forget your fingers, eyeballs, and your human brains interacting with the devices via the CLI. We can use code to interact with devices and process the data and run tasks for us. So this is much more efficient, reusable, reliable if the code's well written. But how does the code on our laptop talk to the connected devices? So we can write some Python on our laptop, that's all very good, but how do we actually use that to speak to our network? So step forward, the API. Okay, so API is the application programming interface. This works on a request and a response model. So we send data, simple stuff, we send data and we get data back. So you could say, oh, well, the CLI is essentially an API. In a way it is, yes, because we send our show commands and then we get our output back, or we send our configuration commands and then we see a kind of response from the device. You could say that, but I'm not talking about those type of APIs. I'm talking about much more modern APIs like a REST API, which we'll be going into. So, and the thing is that a lot of things, if you plug it in today, if you power something up today, there's a good chance that there's going to be an API on it. APIs are appearing on a lot of devices. Well, except for the vast majority of deployed networking kit. So I had a quick look online for some things to find out, some APIs that are out there. And so probably I'm sure you have used YouTube, or you're watching this on YouTube, sorry, or you've got a Facebook account. Well, those websites developed by software engineers, they have APIs on them. So Facebook has a way that you can interact with Facebook. It's all open, it's all public. You just scroll to, I think it's the developers section of Facebook, and it will it reveals a world of how to interact with the website via its API. So you can send code to Facebook, or you can send code to YouTube and get information back off of it. Also, where we've got the development of smart homes with more devices. So devices in our homes, such as washing machines and fridges and things like that, TVs especially, they've been running software for a long time. But where you get this kind of interconnectedness that we're seeing today with the smart homes, with the home automation, that's because these devices now have APIs on them. So you can see here you've got the Samsung developer program there, where you've got well, it's called the Smart Home Cloud API. So we've got devices that Samsung are producing that have got APIs on them, and you can learn how to interact with this API. Also, we've got the stranger one, which I've mentioned on a previous video of mine, which is that there's a web API from Oral-B, which means that your toothbrush can record the amount of brushing time and all of these amazing stats. So it's got pressure, brushing time, mode, etc., which is a bit creepy. So you can check up on your kids' brushing habits. And also we've got things like Philips are really all in on this with the APIs as well for home automation. One of the things that they've got is the Hue personal wireless lighting system. So you can do all funky things with your wireless and interact with it. And the way that you interact is via the API. So we're seeing APIs everywhere, not so much on networking kit. So APIs give us a structured way to interact with the software on devices, with applications, and code is the way that we build the requests and handle the responses that come back from the applications. And once we have this data, we can run tasks on it. So you send a request, you get the data back, and then you can do some other tasks off the back of that. So if you get response X, you can do Y. If you get response A, you can do task B. So essentially that's automation there. So we can automate. But the nature of the data, this is key. Because you could say, hang on a minute, networkers have been scripting for years. You know, what's new here? And now the really important thing, so this is what I'm drawing from, in my experience, there used to be some guys that I worked with that would run networking scripts, and they would do a small amount of automation. So what's changed here? What tangibly has changed here? Okay, so in the past, this is the type of thing that used to happen on one of the networks that I ran. We would have PERL scripts running, okay, and these would essentially be automating the CLI command. So what we were doing is that we were still using the CLI as our interface to interact with our network devices. So we were building scripts that would send show or configuration CLI commands to our devices and then get the outputs from those. So as you can see, the CLI remains the interface. Now this is inefficient because the CLI itself, by its nature, if you think about it, vast majority of networking kit CLI, it's written in English essentially. You know, you got show, IP for Internet Protocol, root, you know, for your routing table. So that's something that a human can read. So, but remember that the machine doesn't need to know all of this stuff. It doesn't need to know English. It's not talking to it doesn't think in English. It thinks in bytes. So the CLI, it's inefficient because it's humanly readable for the input and output. And so we have our character here saying, "Hey machine, you need to be able to speak human." The correct response for that is on the screen now. Okay, so changing tack slightly. Right, so we're not doing PERL for the CLI. So we're not going to be sending CLI commands using PERL. So what are we going to do? We said that we're going to use code to interact with the device, with our network devices. What are we going to do? So step forward, and now for something completely different, step forward, Python. So this is the network engineer's go-to language. So here are some of the reasons why it is popular. It's a great language. It's high level, it's readable, very popular. Now, this is a really key point here, the fact that it's popular. So it has an active community. You know, if everybody, it's one of those cases where it's actually pretty good. With software development, when you're looking at something new here, it's actually pretty good to be doing something that everybody else is doing, because then you get a community. You know, with Python, if you hit a problem, if you put that problem into Google, there's a pretty good chance that you're going to get a good answer to that query that you have online within a few clicks. So this is a really positive point about Python. Also, you've got loads of libraries. So you've got the great standard library. So this is essentially code that's already written for you, and then you've got other third-party libraries. So this is code that someone else has written to solve certain tasks, and you can all import those. So there's loads of libraries that you can use. Also, this isn't playground stuff. It's used by Google, Industrial Light and Magic, and there's loads of coding tutorials to get you started on this stuff, and it's very much the one that network engineers are using today. So what we can do is we can write our automation task in Python. So how do we get the data for Python? So if we're going to interact, how do we do that? Right, so one of the things which I've mentioned in previous videos is the NetMiko project. So this is a project, it's written in Python, and it's about how to log in, issue show commands, and then capture the output. And over on the right there, you can see a really simple NetMiko program that I've put together there. So what we do is I'm importing NetMiko, and I have this connect handler here. This is where I put in my device detail. So, you know, very, very easy to read. I've got a device type. This is the thing that handles the interaction. I do have a dedicated video based upon NetMiko. I'll put the link on the screen now for that. Here's your IP address. There's my username and password. Shout out if you can reference the literature reference there. And there we go to connect, and I send a command. I'm just showing a show version, and I want to print that out. So really easy stuff. Now the intelligence of NetMiko is this part, the interaction between our laptop and the software that's running on the network devices, which is no small task. You know, this is really important stuff. But this is legacy, and it knows it. If you look up, so the chap that wrote NetMiko and maintains it, Kirk Byers, he actually says this is legacy, because this is you know, for the astute, those that are paying attention, you'll realise the fact that this isn't that much further along the line than PERL, from how I was criticising PERL, because we're still using, as you can see there, we're still using show version. So we are using the CLI to interact. We are interacting with the devices inefficiently. We're using English to speak to these to actually ask these questions via the CLI. But the guys that run NetMe code, they know that. Okay, so let's move on to structured versus unstructured data. So you can say that CLI commands and the output is unstructured. Well, at least it's kind of semi-structured. So and one of the problems with this is the way that it's presented. If you ask for something like on the screen here, I've asked for the MAC table off of a device, you don't just get the MAC table back off of the device, you get lots of other information as well, which makes it easier to read for humans. So if we, what I've got here, I've got Comware and I've got an Aruba OS switch. So I've issued essentially the same command, display MAC address and show MAC address, okay? And what we have here is the fact that as humans, we can read this quite easily because we've got MAC address and then we've got the MAC. So because I know computer networking, I recognise that as a MAC address. I've got the VLAN there. So I've got these columns. You know, my brain can parse this and make sense of it pretty quickly because I've got my columns and I've got my data below that. That's fine. And if we look down though, and this is a problem, the same information between the different operating systems that you might have running on your network, they can be presented in very different ways. So if we go, there's Comware there, and there, if we look at the Aruba OS switch, you can see very different, same kind of information. We've got the ports, so we've got ports here, we've got the VLAN, so we can read that quite easily because we're looking at the columns, then we've got the MAC address, but it's much harder for a device, for software, for a machine to parse this information because it can't read this like we can. It can't just look at this. And an important point here is look at the different ways that the MAC addresses are presented. So we can read that and say, okay, yeah, well, we've got, this is our MAC address here. Also, this is another valid way of presenting MAC addresses. But the problem is you have to be able to tell the software, this is the MAC address, or this is the MAC address. And when you have differences there, you have to write code around this output to tell the device this is what a MAC address. A computer can't just read that and say, oh, that's a MAC address. You need to write code to tell it that that's a MAC address. So if anything changes, I'm sure you can appreciate, then you need to write more code. So that's really rigid. This kind of way of getting information off of a device is rigid. So we as engineers, we learn what information to pick out. Humans are great at pattern matching, but machines are not. So we need to build, as I've mentioned, we need to build the code for this, which is very inefficient. It's rigid, but you change the operating system, you've got to change the code for the parsing. So this is not a good way forward for us. So let's think about this in another way. So communication, to really drill this home. Communication is easier if it is structured. So looking at a simple sentence within English, I think this really drills this home. So it is the sentence being, it is a truth universally acknowledged that a single man in possession of a good fortune must be in want of a wife. There we go. We've got capital letters, we've got commas for the pause, and then we've got a full stop, which shows us where the end. So when you're reading a book, you have this structure in there that you learn. This is English, so this is the English language grammar. Now here's some English, so it's much harder to read this book. So this is an extract from a book that is notoriously hard to read. So this is James Joyce's Ulysses. It's something like, in the paperback edition, it's the last 60 pages or so, I think, hardly any punctuation. Very hard to read. I know the concepts of this book, if you ever try to read it, are hard, but actually the structure, or the lack of structure, makes it that much harder to read. Not surprisingly then, maybe, that Goodreads website lists its users list as the most difficult novel to read. Number one, there we are, Ulysses. I know that it's long, I know that there's difficult subjects to it, but One of the things that really doesn't help is the lack of structure. So for us to consume that data, I think we can agree that structure is good. It makes the data easier to consume, and that's for machines, but also for humans. So how does Python consume data? This is where we're going a bit deeper into Python so that we can really pick out what is happening here. Okay, so let's pause for some Python data type. Don't worry if you don't know any Python or you haven't done anything before. We're not going to go much deeper into the specifics of Python, but I think just looking at these, shining a light on these, really helps to illustrate what we're talking about when we say that things are changing in terms of network automation in the world right now. Okay, so here's the different data types that we see. So common data types that we see within Python. So you've got integers there, so that's just numbers. Then we have strings. And strings are letters or numbers between quotation marks, single or double quotation marks. We also have dictionaries. So this is curly brackets, and this is a key and a value. So this is how we store information. We have a key, which we can call, and then that will present a value. Okay, so it's called a key value pair. Fine. Another one that we've got is a list. So this list can be a list of integers, or it can be a list of strings. And this is where we have the square brackets, and we have, this is a list of strings. So we've got John, Paul, George, and the other one. Okay, so that's a list, right? So we've got integer, string, dictionary, list. Great. Now, to illustrate that problem of structured versus unstructured, let's look at the problem. I think this drills home the problem with the captured output that we've got from show MAC address if we use NetMiko to do screen scraping on this. So that's where we log in, we issue, and then we take the information. Okay. The big problem here is that all of this essentially is a string coming back from the device. This is how it's presented in Python, okay? So you might as well just put a quotation mark there and a quotation mark there. If you use the CLI, and everything in between is part of the string. So you can think like all of this, all the headers, all of these dashes, all of the MAC addresses, all the port numbers, that's all one string. Okay, so this is the code that we need. So this is the important stuff. This is our MAC these are our MAC addresses. That's what we're after. We don't want all of these columns. We don't need all of the stats and counters or anything like that. That's for humans. When we're asking for the MAC addresses, that's the information there that we need. Okay, so as I mentioned, what we need to do is we need to write code so that a device can parse that information, okay? And one of the things about writing the code to parse that information, it is much easier if it's a known value. You can do a kind of if lookup on a certain value if you know that it's going to be there. If you don't know where it's going to be, or if you're not sure beforehand what the MAC address is presented like or where it's going to be in the string, that makes it much, much harder to write code to say to the device, pick out the MAC addresses. What we're essentially saying is we're saying to the switch, hey, give me your list of MAC addresses in this example, and the device cannot interpret that. It doesn't know what to give us. Okay, so back in 2008, around that time, Google took a stab at solving these problems. I think at the time they were using a lot of Cisco equipment, and they wanted to try to do some network automation. So what they wrote, and they've now open sourced, it's up on GitHub, is TextFSM. So this is having a go at this, right? So what it does is it uses regular expressions to build templates. Okay, so over on the right there, you can see an example of one of the templates for Cisco IOS, which will pick out variables such as the version, uptime, etc., etc. Okay. So these in themselves, these templates are pretty complex. And the thing is, remember that problem that I said, this stuff is rigid. If there's any changes or if you're using different operating systems, you need new templates. This stuff is inefficient. When really all we want is the MAC addresses from the device. Or in this case, we want the show version information. But I'm sure you can appreciate the fact that the problems in the past with parsing the output from the CLI is that it is inefficient. It's not giving us the information that we need in a structured format. Okay, so let's circle back round to those data types. Remember that I said to you about the dictionary. Okay, so here's a dictionary here. What I've got is I have a dictionary. This is from Python. Okay, so here we have a dictionary called mydict. In that we have key value pairs. So I've got weather and it's rainy, location is London, and the temperature is 15. Okay, so you can see that's a mixture of strings, and I've got an integer there. So this is my dictionary. Okay, key value pairs. And what you can do here over in the bottom right, you've got an output here from where I've called my dictionary, and I've called here. This is how we do it within Python. Okay, I have referenced my dictionary, and then I've called the weather key, and the response, you'll notice, is raining. Okay, so what we have there is I've called the weather key, and I've got the value as response. Now look at the next one, location. We call location on mydict, and we get London, and you know, obviously if we call temperature we get 15. Okay, so this is interesting stuff here, how this is presented. So this is a different way of presenting data. Now what if we could do this with a networking device? What if we could, rather than just asking for single pieces of information such as the temperature, what if we could ask for the MAC table and actually just get back the MAC table? What if we could ask for the ARP table and get the ARP table? Well, that's what we're doing with an API. This is the key difference. This is what I really am making this video about, which was a kind of a revelation to me when I was really confused about what was happening in the industry today with network automation. What is changing? Why is all this stuff different from our PERL scripts, from our CLI? It's because with the API we can ask questions and get the response in a structured way. Okay, so it's much more efficient, much more aligned to what we're actually after for moving on to automation. And you may be asking yourself, okay, so how do I get hold of one of these APIs? I mentioned Facebook, I mentioned YouTube. What about networking devices? Well, Aruba OS Switch has an API on it. So I've done videos about this in the past. So I think most of the Aruba OS switches that are running 16.02, so that's quite an old version of code. I think it was last year sometime. They have a REST API on them. And so what is REST, right? I've mentioned APIs. So when I'm talking about APIs, really, for every one of those devices I think that I was talking about, pretty much the examples that I've given, I'm talking about a REST API. So this is representational state transfer. The way this works, very simple stuff. If you've ever used a web browser, which I'm sure you all have, you've pretty much got the knack of how you might use a REST API. So what we do is it's via HTTP, we send a GET to, so this is our request for information. We can send an HTTP GET to the REST API that sits on our switch, and we can get information back from it in a structured format. So that can be in JavaScript object notation, so JSON, or it can be in XML. So most of the devices that we're talking about, I think all of the 16.02 with the REST API, you get JSON back. Okay, I'm not going to go into big details about what that format of that data is right now. The thing to take from this is the fact that the information that's coming back is not coming back in the CLI format and we need to parse those strings. It's coming back as structured data already. It's coming back as JSON. It's coming back as XML. And that's much easier for our code to process. Okay, so how do we enable this? Well, it's very easy. You just turn on the REST interface. Okay, there's the command up on the screen. And also, so you might say, okay, so how do we send these HTTP requests? Well, that's also very easy. Now, there's different ways to do it. You don't have to do it via Python. Python's just one way of doing these information requests. You could use curl. You could use there's a application by Google which is specifically for this, Postman. I've used that in other videos, giving you a demonstration about how to actually do that. Here's an example of using Postman to send information. This is a GET to, here's our IP address, 192.168.1.29. We send it to the REST and we ask for, guess what? Mac table. What do we get back? We get this structured data back here, and there you can see MAC addresses. The structure of that looks very much like a dictionary, doesn't it? We've got MAC address, and then we've got the MAC, okay? Now, here's a really simple, so this is, as I mentioned, there's different ways to grab this information from the devices. This is a way of getting it via Python. So very simple. There's really not much to this may look quite hard to read if you've never done this before, but there really isn't that much to it. So what we do, I'm using this is a third-party library called Requests, which is the kind of de facto way of doing this within Python. Very popular library. We build a URL. So there's our IP address. We send it to REST. We ask again, hey, we're asking for the MAC table from our URL. And we create an object there which is going to send to this URL. It's going to do a request.get to our URL, and then we're going to print that out, and we're going to print it out as JSON, okay? So if we enter it, so this is what you need to do. You import the library, you build your URL, you send a request, and then if you're going to do some, what you've got to remember is that I'm just printing this out for the demonstration purposes, like for my presentation. I wanted to show people something up on the screen. If you were doing network automation to a high level, you wouldn't be printing this stuff to the screen. You would be parsing this information. You would be passing it off to maybe some kind of GUI for it to be presented, or maybe you'd be running some kind of checks, some ifs, some booleans over the top of this to find out whether this information was meeting certain criteria, and then you would automate and run tasks off of this. But the really key point I'm trying to drill home here is that automation must have the data in the right format so that you can then do those other tasks, that you can do that automation, okay? What we're doing here, we're printing out for our eyeballs, right? And what we get back is, there you go, there's your MAC addresses, okay? And down at the bottom here, so this is much more what we're after. We ask for MAC table, we get the MAC table. Good stuff, right? What I've done there, I've done a type on that so you can see actually the class of this information that's coming back, that's a dictionary. So that was the important point about the Python data structures. We're not getting back a string that's hard to parse. We're getting back a dictionary that's actually much easier to draw, because it's structured. It's much easier to get that. So we can ask for the weather and get back that it's rainy. We can ask the temperature and get back that it's 15. We can ask for the max off of this table and get back the max. Okay, so it's a dictionary, right? And there you can see, so I've done, with only a little code in this printout here, I've done a for loop over that. Don't worry too much about this, is it? You can see it's 2 lines to print out. I've taken the information, I've said, give me the MAC table, I've done a for loop over the information that we got back off of the device, focused on the MAC table, and I've said print out the MAC addresses, and there you go, there's your MAC addresses. So you can imagine you can then take those MAC addresses, pass them over to some other code to do some checks on them. And what I'm sure you can appreciate is the fact that there's no complex supporting code, there's no regular expressions in here. As long as and if you think, if you had another operating system that had a REST API in it with very similar structure to this, you could grab the MAC addresses off of that one and the other operating system and not have to rewrite all of those templates, all of that parsing code. This is good stuff. This is the big difference that's happening within networking nowadays. It's REST APIs on your network devices. That's what you need. So you may be asking yourself, how do you know the URL that you need to send the get to get the information? Well, the schema is publicly available online. And you may say, is it just about reading data? Well, no. So you can do a get to read data off, but you can do a post to configure a device. So actually put information, as long as you put it in the right format, you can send information to configure devices. And you can say, oh, right, so another query would be, what are the drawbacks? Now, the thing is, at the moment, the API on the Aruba devices doesn't have parity with the CLI. So there's lots that you can't do right now, okay? So you can't think this is the thing. This is early days for the API. So there's lots of things that are in the CLI that you can't do via the API. So that may not fit you for your production networks right now, but more functionality is on the horizon. This stuff is only going to build and build, and it's really good to understand what's going on in network automation. Getting in at the ground floor right now on this hot topic is a good idea to play around with this stuff. Maybe not. Maybe you wouldn't be able to use this for your production network because you would have to drop into CLI for so much nowadays. Or maybe you could mix it up so that you can automate some tasks via the API and use CLI for the rest of it. I think the important point is that this is going to grow and grow. Okay, so talking to a room full of jaded network engineers at a conference, the typical response between some of the less enthusiastic, or some of the guys that have been asleep for most of my talks, their typical response would be, this seems like a lot of work for a bunch of show commands. I mean, why would I bother doing all? Why am I going to bother learning Python to just run a bunch of commands? You know, what's the point of all this stuff? And that is a valid viewpoint. But remember, this is just the start. So printing out the information for our eyeballs, that's not what this is all about. That's just when we're in a demonstration and we want to show the audience, or I'm doing a video and I want to show you something that you can actually consume yourself. We have to print it out. But this isn't about printing out the information for your eyeballs. This is about machine-to-machine communication. So this is where we can tell the machine, go and get the data for us like this, get it back, and the machine can consume it. So Python can consume that very easily. Then we can run some loops. We can do some if, else, is, not, some for loops over the information. So it's the something that we're doing. This is the important part. This is our automation. Now, the other thing with this that's very interesting about that kind of ecosystem of applications using APIs, okay? So what you have is that you have all these other devices with REST APIs as well. So you can think, hang on a minute, I could get a network device to talk to things like the Amazon or the Google Home, you know, Alexa. You can have the Philips Hue turning red. A colleague of mine has already done this, where you get a report off of a device, a kind of critical failure, and then a red light appears. You know, it's this kind of stuff, though, you know, it's kind of fun to think about some of the things. Some of these will turn into really serious use cases that we can use within networks, so that the network and the devices and these peripheral devices, they can all speak to each other via APIs. That's really important. That's a big step forward that we're taking right now. So these demos, all of this stuff, I mean, there's a few Alexa demos doing the rounds at the moment, but the real problem, the real power comes when the API calls within the network, okay? So what if you could have API calls between the core switches that then can configure an access layer device? So we're talking, you know, zero-touch provisioning, ZTP on steroids, where you can have a device that you plug in, it fires up, the core device can then start interacting and configuring it based upon certain information. You could have things like self-upgrading networks, where the devices can actually steer the traffic away from an upgrading switch. Imagine that, using API calls to configure the connected devices to say, hey, don't send traffic to me. So it's a bit like a kind of graceful restart, automated, where you can say, all right, I'm not running a core switch thinks to itself, I'm not running the version of code that I need to run, send it to my buddy, I'm going down, traffic flows over the other device, okay, now I do my reload, comes back up, send the traffic back to me, all via API calls. Imagine that. Or I thought this was a fun one. What if you had a kind of ordering system that ran an API as well? When a line card starts to fail, the switch can actually raise an RMA for itself, order the line card itself before it fails. These are just, maybe you think those are kind of crazy stuff. Maybe you don't think that we'll go that far forward with networking, but it's just some of the ideas that you can, once you get this stuff working via APIs, talking to each other in software, the possibilities are, they're big. Okay, so let's pour some cold water on this, all this enthusiasm. So with great power comes great ability to break things, okay? Doesn't all this automation mean a massive blast radius if something goes down? So if we can configure a whole network with one command, doesn't that mean we can destroy a whole network with one command? Well, yeah, it does. We can do. But the thing is, this isn't just a problem for networking, okay? There's huge amounts of automation in lots of areas of IT right now. And they are living and breathing and going forward. There are huge outages. These things happen, and it's that we are learning from these and moving forward. Okay, so as an example, this is the AWS outage 28th of Feb 17. It was a biggie. Okay, so they released a statement. I really love this way that companies deal with I don't love the outages, obviously, but the fact that they do give a lot of information to the users nowadays in a statement to say what actually happened. So essentially, the long and the short of this, if you haven't read it, is that so the TLDR of this is that humans make mistakes. It was bad news. I mean, it was news headline level bad. So essentially, it was a typo. And this is from cnet.com. A typo blew up part of the internet on Tuesday. So it was an authorized S3 team member was using a playbook, so executing a command. So this is automation, possibly Ansible playbook. Which was intended to remove a small number of servers, but took down a lot more than it was supposed to. So this is exactly what we're saying. If you can take down multiple servers in one go, if you put in the wrong thing into your playbook, you take off far too many. There's a possibility that you can cause a massive outage, and that's exactly what happened. So what do you think the response was, though? The fact that there had been this problem. Do you think it was less automation, more humans typing at keyboards via CLIs? Of course not. It was streamline those processes, bring in more training, more automation. So this is again from the statement. We are making several changes as a result of this operational event. Key point here: we have modified this tool to remove capacity more slowly and added safeguards. Okay, so this is it. There's more process, more safeguards around their automation to make sure this kind of thing doesn't happen again. You know what they're doing there? They're essentially stopping humans making the same mistake in the future. It's not less automation that we need, it's more automation. Okay, so in conclusion, networks are scaling up, IT budgets are going down, so we can't type fast enough for all of the stuff on the networks. APIs are everywhere, and that's a good thing. This is the way that devices interact with each other. We're seeing this on networking hardware now. But this isn't your dad's PERL scripts, okay? APIs enable us to move beyond the CLI with consumable structured data. It's early days. The vast majority of networking hardware out there doesn't have an API, but some of the new ones do, and I'm happy to say that Aruba OS Switch, since 16.02 on the code, has got it. It's definitely something that you should be looking at and getting involved in. I mean, the bottom line, it's fun. Okay, so that was Moving Beyond CLI, a beginner's guide to network automation and APIs. I'll be doing other videos which are looking more specifically at some of those network automation tools that I mentioned. But for now, thanks for watching. Please like, comment and subscribe, and hit me up on Twitter at @JoeNeville_. Thanks very much. Goodbye.